Hello and welcome to 90East. In this video we'll be looking at relative atomic mass and standard atomic weight and how they relate to atomic mass. You'll remember from our previous video that the atomic mass of an atom is the mass of that individual atom itself, and that different isotopes, for instance carbon-13, will have a different atomic mass. So the question is, if we had a sample of a chemical element with multiple types of isotopes in it, how do we know what the average atomic mass of the atoms within that sample would be? Well, we look at the chemical's relative atomic mass. And this is something that can sometimes be referred to as atomic weight, and that is the old terminology. So we'll be sticking to relative atomic mass in this series. To calculate the relative atomic mass of a chemical sample, we need to know a few different things. Firstly, we need to know the number of isotopes within that sample. Secondly, the relative amount of each isotope in the sample. And thirdly, the atomic mass of each isotope in the sample. And then we can plug it into an equation that looks like this. The equation could be very, very long or very short. This equation here is for 3 different isotopes, 1, 2, and 3. Where N1 is the number of atoms of isotope 1, and Ma1 is the atomic mass of isotope 1. Let's look at an example to consolidate our understanding. Say for instance you were to have a sample of carbon atoms, 100 atoms in fact, and 99 of those atoms were carbon-12 and 1 atom was carbon-13. We've got the number of isotopes, which is 2, carbon-12 and carbon-13. Their relative abundance, we've got 99 carbon-12 atoms and 1 carbon-13, and we know their atomic mass already. Let's calculate the relative atomic mass using this equation. We plug in the numbers, so 19 atoms that have got atomic mass of 12 and 1 atom with atomic mass of 13. We've got 100 atoms in total in the sample. Using our calculator we can work out that the relative atomic mass of carbon in this sample is 12.01. But sometimes different samples will have different proportions of isotopes, and so their relative atomic mass will vary. For example, a sample that you take from the bottom of the ocean will vary to the one that's taken from the top of the mountain, or even a sample from outer space. And while this can be helpful in helping us to identify where samples are from, it's also useful to have a standard, for instance when you're in the lab. And that's exactly why we have another value, the standard atomic weight. And this is the mass based on a normal sample of isotopes. It's the value that you'll see, for instance, quoted in the periodic table. So just to review what we've covered in this video, the atomic mass can be described as the mass of an individual or single atom. But because we have different isotopes within a sample, the relative atomic mass is the average atomic mass within that sample. And because samples vary, we have a standard atomic weight, and that is the average mass in a normal sample. We hope that you found this video useful. Please send us a message if you've got any questions, either directly through YouTube or via email to 90easttv@gmail.com. Thanks everyone.